Hello and welcome. These are the solutions to quiz 19. I will just be posting sort of random quizzes with some keys once or twice a week, is what you should expect to see. So, which compound below contains an atom with an oxidation number of +6? So, we got a 2 plus and a 2 minus for the calcium and oxygen. Think of SO3, 2 minus. We got a -2 times 3, so a -6 for the oxygens. Sulfur is going to have a +4, so we can subtract the 6 and get the -2 overall charge on sulfite. So we're going to have a +4 for sulfur, Na3PO4. So sodium's plus, oxygen's -2, but PO4, 3 minus, -2 for the O, ordinary charge on oxygen. Remember, oxygen's only exceptions are peroxides, superoxides, and compounds with fluorine. This is none of those. So -2 for a -8 for the 4 oxygens. We're summing these up. So phosphorus is going to have an oxidation number of +5, so we subtract 8 and get the overall charge of -3. H2SO4, that looks like the winner, hydrogen +1. So let me do H2SO4 over here, -2 +1, so I get a +2 for the 2 hydrogens, -8 for the 4 oxygens, and so a +6 for the 1 sulfur. And then if we want to just make sure it's not D, we got a +1, -3 for Ag and the O. So chlorine there is going to work out to be a +5. So the answer here is answer C. Number 2, which statement best describes the reaction below? So is it an oxidation reduction reaction? If so, what's being oxidized and reduced? So we have an oxygen here, ordinary -2, -4 for the 4 O's. We got a +4 chlorine. If we look in our products, that is going to be changing, -1 for the chlorine and HCl, and then +1, -2, so -6, +1 for a +5. So we have chlorine actually undergoing a change from +4 to +5 and to -1. So it looks like 5 of the chlorines go to the +5, and then 1 goes to the -1. And everything else is probably staying the same. Oxygen's -2, hydrogen's +1 in the other cases here. So H and the O are unchanged. So chlorine is being oxidized and reduced in this reaction. So chlorine is the atom undergoing both the oxidation and the reduction. So we got a chlorine +4 going to a chlorine +5, and we have a chlorine +4 going to a chlorine -1, and then the actual count here is we got 5 going this way, 1 going to the -1. So we got 5 chlorine atoms that are losing an electron. So this chlorine atom here is the one that's undergoing the oxidation. Loss of that electron is oxidation. And then chlorine here is picking up 5 electrons. So it's gaining electrons, so this chlorine atom here to the Cl- is the one that's being reduced. It's gaining 5 electrons that were given off by the other chlorine atoms. Okay, moving on to number 3. Which statement best describes the mixing of equal volumes of lead nitrate and Ki? So equal volumes of equal concentrations. Well, the reaction here, when I add these together to form PbI2 and KNO3, where PbI2 precipitates, so I need 2 Ki's to react and 2 KNO3s to form. So if I add PbNO3, I need twice as much Ki, but I don't have twice as much Ki present. So what's going to happen is that we're going to be left behind with some excess lead nitrate. So if we imagine having the case here where let's imagine we have 2 Ki's. Let's imagine we have 2 PbNO3s. So I drew 2 PbNO3s and I drew 2 Ki's so that we can have equal concentrations and then I'm mixing equal volumes of equal concentration. So I have equal number of lead ions and K plus ions. And so then I just have twice as many nitrates because there's twice as many nitrates on a lead nitrate. Okay, so now what can I lasso out here? I can lasso out like a PbI2, and then it turns out that's it. So I make one PbI2, and then look at everything else that's in excess. Okay, so I'm left behind with my excess lead ion, my excess nitrate ions, and I'm also left behind the other nitrate ions and then the K plus ions. Because the K plus and the nitrate ions are spectators in the reaction, so they're going to be left behind regardless. Then I'm also left behind a little bit of that excess lead ion. So K plus is present in an appreciable amount in the supernatant fluid, nitrate's present, lead is present, both A and B are true. All the above are true. So we have an appreciable amount of potassium ion, nitrate ion, and lead ion in the solution. Tricky question, but try to picture that reaction taking place and think about what's present in excess. Number 4, which substance is a weak electrolyte in water? So our weak electrolytes are going to be our weak acids and weak bases. So weak acids are the 7, or the acids that aren't the 7 strong acids, and the weak bases is basically just NH3. Okay, so a weak electrolyte. Ethanol is a non-electrolyte, so that's not an answer. Acetic acid is a weak acid, so that's a weak acid, weak electrolyte. So that's true. HClO3 is a strong acid. CaOH2 is actually a strong base. It's also just a water-soluble ionic compound. So the answer would be just the acetic acid. All right, number 5. Which statement is true? Sodium can be oxidized to sodium plus with copper nitrate. Sodium solid can be reduced to sodium plus with copper nitrate. Copper solid can be oxidized to copper 2 plus with sodium nitrate, and then copper solid can be reduced to copper. Okay, so this is an activity series question. You can look at the activity series. You'll have it if you need it. I don't think you actually need it for this question because you should know that sodium is going to be higher on the chart than copper. We make pipes out of copper. We don't make pipes out of sodium. There's a reason for that. Copper is less reactive than sodium in terms of their relative ability to lose electrons, to be oxidized, or just in general in terms of their reactivity trends. So copper's lower on the activity series. Again, you could double check that, but I think we can probably picture that as well. Now, part of this also just has to do with terminology. So sodium can be oxidized to sodium plus. Like if that occurs, that is an oxidation reaction. That would not be a reduction reaction. So sodium cannot be reduced to sodium plus because reduction is the gaining of electrons. To go to sodium plus is the loss of electrons. Okay, so then copper cannot be reduced to copper 2 plus either for the same reason. So the real question here is if I put sodium into a solution of copper, will it react? Or will copper react if I put it into a solution of sodium ion? Let's think of C first. Because I just said copper is not very reactive. If I put something that's not very reactive in terms of copper metal into sodium nitrate, the real thing that you'd be considering, would I form, in this case, copper 2 plus nitrate to AQ plus sodium metal? If I did, you can balance it out. You'd have 2 of these, 2 of those, and we'd be good. But the issue here is that I can write the reaction, doesn't mean it'll happen though. Copper is just not reactive enough. I'd be taking something that's not very reactive and producing something that's more reactive than what I start with. That doesn't sound possible. So there's no reaction that occurs in C. So it's not B or D because of the terminology. It's not C because of what we just talked about. But then sodium should be able to be placed into the copper solution. So CuNO3, 2. And then the product should be sodium nitrate because we're forming sodium plus nitrate, staying as a minus, and then forming copper solid, and then balancing this out, 2 sodiums, 2 NaNO3s. Looks like we're in balance. And so sodiums can give off electrons. So sodium goes from sodium 0 to plus as copper goes from a 2 plus to a 0. So sodium is giving the electrons to reform that lesser active metal. So a more reactive sodium produces a less reactive copper. That's good. That's what can take place. Number 6, the conductivity of a solution is directly proportional to the number of ions in the solution. Which solution contains the lowest conductivity? And so we just have to think here that we're going to get 7 moles of ions per 1 mole of chromium nitrate. So if I think of the ion concentration starting with E, it's going to be 7 times 0.25. 0.25 times 7 is 1.75 molar is the ion concentration. Iron sulfate is water soluble, but I get 3 plus 5, or 3 plus 2, so I get 5 ions, so that's going to be 1.5 molar in terms of the concentration of ions. I get 4 moles of ions for iron, for potassium phosphate, so that's going to be 4 times 4, that's 1.6 molar in terms of the ions. K2CO3, water soluble, I get 3 moles of ions, that's 1.5 molar. But then I only get 2 ions off for KBr. So I get the K plus, the Br minus, so 2 moles of ions, 1.2 molar. So it's just going to be answer A. So A would have the lowest conductivity of the listed salt solutions. And then finally, number 7 and 8, which precipitate forms when calcium bromide and silver acetate. So this is just one of the ways of writing acetate ion. So I take the compounds here. Calcium acetate could form, but that's water soluble, so that's just going to remain as the ions. And then AgBr should form as the precipitate. So that should form because that's insoluble. So I'm just mixing these two anions with each other, and the formula should be Ag plus, Br minus, plus minus, so it should be AgBr. Of course, silver plus is the only common ion of silver as well, so there's a couple ways you might look at the proper formula for 7 is coming from an understanding of the charge of silver, the charge of acetate, and an understanding perhaps from nomenclature that silver only forms a +1 common ion. And then finally, number 8, which of the following is true for the combustion reaction of ethane? C2H6 plus O2 goes to 2CO2 plus 3H2O. I'm going to leave this as a fraction because that doesn't quite matter for the problem, but that will be 7O, so I need 7 halves O2. Now the key here is we have a 0O going to a -2 because the oxidation number of oxygen in O2, elemental form, is 0. In molecular compounds, it would be -2, except when it's paired up with F or whenever it's an peroxide or superoxide. So these are the exceptions for compounds with O. This isn't one of those, so it's just an ordinary -2. So carbon goes +4. So carbon here would be +1 for the 6 hydrogens, so that's +6. We could have a -6 for a -3 overall, the oxidation over carbon and ethane. And then -3 is going to a +4. So we have the carbon atom losing a bunch of electrons. Hydrogen staying the same because the oxidation number of H in water is also +1. So the H atom is unchanged here. And then oxygen's going from a 0 to a -2, so it's gaining electrons. Okay, so the carbon atom is losing electrons. Losing electrons is oxidation, so the carbon is oxidized. And then the oxygen undergoes the reduction, so oxygen is reduced. All right, that's the solutions for this one. Thanks for the attention.